Hi, in this video we will demonstrate how to set up the Influx management envelope using DrillSoft HDX Plus. In this case we'll use an offshore well with oil-based mud. So just to confirm, we can go to configurations, go to fluids, and we have them set up as oil-based muds, and we can check the rheology optimization to see which one is the best fit model. And with 2.29% error, the Herschel-Buckley method is the most optimum one. And look at power law, being in plastic, Newtonian, API RP, 13D. So let's go back to best fit and override. We have oil-based mud with 100% oil, 0% water. So first off, we'll have to go to the sidebar, to well control, influx data, and type in the depth of entry for the gas kick, the reservoir pressure, reservoir height, permeability of the formation, gas gravity, pit gain, and drainage radius. The pit gain will be overridden by our IME settings. So to go to the IME, we can either go to Tools and then click IME or hit Control I. So when we first open the IME, we'll see a screen like this. We can move to pre-influx and then show area and legends. That way we have better configuration. And we put in our RCD limit, circulating pressure, and the connection back pressure. So these are the pressures for our surface. These are the surface pressure limits. And then the influx detection limits. The minimum I'll detect is 2 barrels and the maximum 10 barrels. And then the LOT at the shoe and whatever our flow rate is that we want to circulate these kicks out using the IME. So once we have these values, we can remove the gray area by typing 100. This is a better view of the graph. We can move this to 12. So now we can see what's going on here. As you can see, we're limited by the LOT pressure line and then the connection back pressure line. And this is our 2-barrel line. So anything anything less than 2 barrels, we're in the OK zone up till about 200 psi or so. And then in the yellow, we'll have to make adjustments on our processes. But this is pre-influx, so we'd have to run this simulation to get the actual results. And keep in mind, this is oil-based mud, not water-based mud. So let's go ahead and hit start. And as you can see, it immediately starts by injecting a gas kick of 2 barrels, and it'll start populating this table. We can speed up this simulation. So we can see our kick intensity is 0.538 pounds per gallon. Our shed and drill pipe for this kick is 209 psi. The influx volume is 2 barrels. The stem pipe pressure after influx is 884, and the surface back pressure after influx is 240 psi. So we've successfully circulated out the first influx, and that led to a maximum volume of 2.07, a maximum flow of 305 gallons per minute. The pressure at the ECD was 1,823, and the maximum wellhead pressure that we saw was 241 psi. So we're circulating out the 1.29 barrel kick with a 0.591 pound per gallon kick intensity. This has a higher kick intensity. And that led to a maximum wellhead pressure of 247 psi and max volume of 1.31 barrels. Max flow rate 303 gallons per minute. Next we're doing our 10 barrel kick. and this came out to be with an adjusted kick intensity of 0 pounds per gallon. And we're circulating out this 10 barrel kick. And we finished IME. So when we look, you can see the maximum wellhead pressure was 171 psi, and casing pressure was 1,753 psi, and max volume we got was 10 barrels. Max flow rate at the outlet was 301 gallons per minute. So if we go back to pre-influx, we can see that the 2 barrel is right here along this line, and we can see what pressure it comes out to. And then we have the second line, which is 1.29 barrel, and that comes out to 247 psi, sorry, 250 psi. And the last point here is a 10 barrel, and that comes out to 133 psi kick intensity. But with adjustments, it's 161. So then we can go to adjusted post-influx surface pressure. And as you can see, we have the line slightly curving down. Since at 10 barrels we can tolerate a slightly higher kick intensity. So we see this with all base muds. If we run the same simulation using water-based mud, let's clear out fluid and reset the temperature. We will maintain the same trends so that we can compare. So we'll switch this back to water-based mud. So it's 100% water, 0% oil. And then we'll go to IME with the same properties and build a graph. And run the simulation. As you see, since there's no solubility, all the gas moves as free gas. You can also observe this in the hole cleaning. It's 100% gas. And we can look at the data table. Go back to trends. So we safely circulated out the 2 barrel kick. That led to a maximum wellhead pressure of 415 psi, casing pressure of 1,826 psi, max volume of 80 barrels. So a 2 barrel kick turned into an 80 barrel kick. Now we're circulating out the 1.29 barrel kick. That led to a maximum wellhead pressure of 419 psi, casing pressure of 1,837 psi, and maximum volume of 72.80 barrels. That is a significant expansion for both these cases. Now we're injecting the 10 barrel gas bubble. All of it is free gas moving through the well. When we finished IME, we can look at the data. So we had 10 barrel kick, maximum wellhead pressure was 331 psi, casing pressure reached up to 1,726 psi, and the maximum volume, that 10 barrel kick expanded to 128.95 barrel at surface. So this was our initial or pre-influx surface pressure, pre-influx IME, influx management envelope, and this is our post-influx management envelope. Are you going to see this slight difference? I guess we can tolerate less pressure. We can expand this graph, see where it crosses. That's a significant change that limits our operating window. This right here is pre-influx, and this is adjusted post-influx. So this is our final IME. When compared to oil-based mud, where the line moved to the right rather than the left, that opened up more operating window for us, while this one limits us. So we covered how to run IME in oil-based mud and water-based mud, and we compared the influx management envelopes and the trends for both cases. Thank you for watching. Please like and comment on our videos. We are very interested in hearing from you. Please follow us on LinkedIn and other social media platforms. And if you'd like a trial version of this software, please contact us at www.drillsoft.com. Thank you.